Okay, another reciprocal quadratic. So we already established in the last one what the reciprocal function is. And what we're going to do is try to break this one down. So you came up with the idea of essentially splitting the 37 into a multiple of 4 so that we could common factor out the value of 4. And the whole idea is so that we can eliminate what's on the denominator, the x squared minus 9. So we're left with negative 4x squared plus 36 plus 1 divided by, again, our x squared minus 2. From there we factor out negative 4, we get x squared minus 9 plus 1, all divided by x squared minus 9. From here we split the question into negative 4 x squared minus 9 divided by x squared minus 9 plus 1 over x squared minus 9. These can now be eliminated, and we'll rewrite the function so that we have 1 over x squared minus 9. Subtract 4. Okay, so this being a vertical translation down 4 units. And this, what we discovered from playing around with it, is a little different. We should go to the original to actually set up our asymptotes here. So horizontal asymptotes. We talked about our proof with dividing by an x value and plugging in an infinite number. But really we look for the highest variable, and they both have the same highest variable, so we look for the coefficients. And the coefficients are negative 4 and 1, so negative 4 divided by 1 is negative 4. So horizontal asymptote is at x equals negative 4. Okay. Vertical asymptotes, we need the denominator to not be equal to 0. Okay. Well, this is a difference of squares, which means it factors into x plus 3 and x minus 3. So if you set those both equal to 0, you get two vertical asymptotes, one at positive 3 and one at negative 3. That makes sense. So and they're both y equals 3. If we were to graph that line, it would just be up and down. So, with this idea being said here, these two vertical asymptotes, because there's two vertical asymptotes, is a little different from our original of 1 over x squared. Normally we just had one vertical asymptote. So because there's two vertical asymptotes to this, this changes our question a bit when we go to graph it. Essentially what's happening is the vertical asymptotes are widening by the root of the last value. Especially when it comes to talking about transforming something, this being our d usually moves things left and right, so you would normally think of this as moving that one vertical asymptote 9 units to the right, right? But in this case, that's not true. We're actually going to root the value of 9, and that's essentially the spacing from our original vertical asymptote. So the root is 3, therefore we have a new vertical asymptote 3 to the right and 3 to the left. So let's say we're going to sketch this new function. Okay, we've discovered from our rough sketch here that we have a horizontal asymptote at negative 4. So let's put that one in to start. So here's a rough sketch. We'll say that's negative 4. Okay, so that's at negative 4. And we have two vertical asymptotes. One at positive 3 and one at negative 3. So say those are positive and negative 3. And positive 3. Same idea, we want to essentially find out where this above function exists at these points. We're going to be looking for a value above 4, right? Because we really want to just know, are we above the horizontal asymptote or below it? Because then that'll give us good ideas for the rest of this function. So I'll take a value to the left of our x, which is negative 3, so let's just take negative 4 and plug it in. So at negative 4, where are we in this function? So let's plug this in. When f is negative 4, we get 1 over negative 4 squared minus 9 minus 4. This becomes 16 minus 9, which is a fifth. Right, 16 minus 9 is 5, 1 over 5. Is that right to you? No, 7th. Either way, we end up with a negative value when we do this because we're having a 7th minus 4. So a 7th minus 4 is a negative value. Oh, sorry, we got to figure out if we're above, sorry, not just 0 itself, but -4. So let's actually be very accurate when we do this. 16 minus 9 is 7, so we get 1 over 7 minus 4, which means we're going to be above -4, because this is a little above -4. So we're on the plus side of this. So in other words, we're probably having something that does something like this at this point. Let's do the opposite side too, a +4. +4, we have the exact same idea, right? Because the 4 would become squared. We're going to be positive again. So on this side of it, we're above. We have something that looks like this. Now we want to check in between. And a simple number to check is 0. So let's plug in f at 0. So that gives us 1 over essentially -9, right? -4. So that's a value that will be less than -4. So we're going to be down here, which is going to have not a quadratic, but similar looking to a quadratic. So here's a rough sketch of what we're probably looking at, and we'll use our graphing calculator to actually graph it out. Let's get rid of some of these here. Our function, and this was our function here when we broke it down, is essentially what we just said. We have a vertical asymptote at -3. Can I prove it by... Can't quite get a hold of the graph. There we go. So as it moves along, we're getting closer and closer to 3, but never touching, and same with on this side here. And our horizontal asymptote is, as you can see, just below -4. So we have our horizontal asymptote here. To be deadly accurate, we want to sketch like some critical values, and again, we use calculus to kind of find critical values. But this is a general sketch of what we were just looking at.